In this video, I want to introduce component and column notation for vectors. So if we consider a vector, say we call it P, that vector describes a shift in position from a starting position to an end position, and it tells us how far it's moving and in what direction. Now, we've been considering vectors geometrically, and that's great, but it has its limitations. So we want to come up with these other ways of representing and working with vectors. So when we work geometrically, it doesn't matter where the starting point of our vector is. We can shift it all around, move it all around the plane, and it doesn't matter, it's still the same vector because it's still describing the same shift in position. But what we're going to do now is give it a set position. So what we're going to do is we're going to position it on a number plane, so on a coordinate plane, and we're going to have the start or the tail of that vector at the origin. So we've got our vector P drawn here in blue, and like I said, we've positioned it so that the tail or the starting point of that vector is at the origin on our number plane. What that means is that we can now describe it in terms of how far from the start to the end it's shifted horizontally and vertically. What we're going to do to help us with describing that movement is introduce two new vectors. So these vectors, we're going to call one of them I and one of them J. So both of them are going to be 1 unit long, so have a length of 1. And the I vector is going to be pointing horizontally, so in the direction of the positive x-axis. And our J vector is going to be pointing vertically, so in the direction of our positive y-axis. So then we can have a look and we can describe P in terms of movements of I and J, so horizontal and vertical. So if we have a look, if we were to put two of those I's along here, so 1 unit and then 1 more unit, exactly the same vector, then that means we've gone an equivalent of 2 lots of that I vector across horizontally, and we've gone 3 vertically of that J, so 3 of those units. So the way we could write this vector P is we could represent it as we've gone 2 lots of I, plus we've done 3 lots of J. So writing a vector in this way is what's called component notation or component form. So let's have a look at that a bit more formally. So a piece of terminology we need to know is that a unit vector has a magnitude of 1. So those vectors of I and J we introduced were unit vectors because they were 1 unit long. For every vector V, there are 2 corresponding unit vectors. So if we take a vector V, we're going to put that little hat above it, and that means that we're finding its unit vector. So if we find its unit vector, we can take that vector and divide it by whatever its length is, which is what we represent with those absolute value signs down the bottom. So the vector divided by its length will give us the unit vector that is parallel to our original and moving in the same direction. Now, if we take the negatives of that, that will give us the unit vector that's parallel to our original, but moving in the opposite direction instead. The next term we need to introduce is our basis vectors. So those vectors I and J that we introduced are called our basis vectors, and they're defined to be perpendicular unit vectors so that I is pointing in the direction of the positive x-axis and J is pointing in the direction of the positive y-axis. Now, if we have a point here, P, with coordinates x, y, then we can describe the vector moving from O to P. We can describe that as x, I, because if we drop this straight down, that's going to come to that coordinate point. We could call it x1 if we wanted to, but it's got a coordinate of x, so we're going x lots of that I vector, plus we're going y lots of that J vector, so y, J, and they should have their squigglies under them as well to say that they're vectors. So like we said, this is called component notation. The other notation that we're talking about today is column notation for vectors. And what we say is that the vector OP can also be represented using the column vector notation as XY or XY. It doesn't matter whether we have the curved brackets or the square brackets. Either of those is fine. Now, I usually tend to go with the square brackets. I prefer them just because I feel like the curved brackets can get confused with our notation when we're talking about combinatorics. So when I'm talking vectors, I usually use those square brackets instead. So if we were to describe our basis vectors in column notation, our vector I would be written as 1, 0, because its x coordinate of the arrowhead is 1, 0. And our J vector, our other basis vector, would have column vector notation of 0, 1. So that's an introduction to looking at vectors in component form and column notation rather than just looking at them geometrically.